Most people see an aircraft carrier and think about size, the runway, the jets lined up on deck, the sheer weight of steel. But size isn't what makes a supercarrier terrifying. Tempo is. Because in modern war, the side that can put aircraft in the sky faster, more often, and for longer, controls the rhythm of the battlefield. And the Ford-class carrier was built around one brutal idea: turn the flight deck into a production line for air power. Not just a runway, a factory. Older carriers like the Nimitz class were already incredibly capable. They could launch massive air operations and sustain combat for long periods. But they were still shaped by decades-old deck layouts, steam-driven systems, and human-heavy workflows. The Ford class takes that foundation and asks a different question. What if we redesign everything, from the elevators to the catapults, for one purpose? Move aircraft, fuel, and weapons faster than ever before. The result is a carrier that doesn't just fight hard, it fights fast. Let's start with the number that gets attention: sortie rate, the number of aircraft missions a carrier can launch and recover. A Ford-class carrier is designed to generate around 160 sorties per day under sustained operations, with the ability to surge even higher during intense combat periods. That's not just a statistic, that's operational pressure. Every sortie is a strike, a patrol, electronic warfare, reconnaissance, or air defense mission. Multiply that over days of combat, and you're looking at hundreds upon hundreds of aircraft movements. For an adversary, that means there's rarely a pause. As one wave lands, another is already arming. As one group refuels, another is taxiing into position. The sky never really clears. And the reason this is possible isn't just pilot skill or aircraft performance, it's the engineering of the deck itself. Take the launch system. The Ford class uses EMALS, the Electromagnetic Aircraft Launch System. Beyond the technical benefits for aircraft stress and efficiency, EMALS has a tempo advantage. It's more consistent and requires less recovery time between launches compared to older steam systems. That smoother, more repeatable launch cycle helps keep the aircraft conveyor belt moving. Then there's the arresting gear on landing. The new advanced arresting gear system is built to handle a wider range of aircraft weights and operate with improved control. Faster, more reliable recoveries mean fewer delays as jets return from missions. But the real tempo revolution is hidden below the deck. On older carriers, moving weapons from storage to aircraft was a complex process involving legacy elevators, long routes, and significant manual handling. It worked, but it took time, coordination, and manpower. The Ford class introduces a new generation of advanced weapons elevators designed to move ordnance more directly and efficiently from magazines deep in the ship up to the flight deck. That shortens the path between stored bomb and armed aircraft. In high-intensity operations, that matters, because the limiting factor in sustained air warfare isn't just aircraft availability. It's how quickly you can turn them around. A jet lands low on fuel and weapons. It taxis into position. Crews swarm it. Refuel, rearm, quick checks, back to the catapult. Every minute saved in that cycle multiplies across the entire air wing. If you shave even a small amount of time off each aircraft's turnaround, the total daily output climbs fast. The Ford class was designed with that math in mind. The flight deck layout itself has been optimized. Small changes in island placement, deck flow, and aircraft handling areas help reduce congestion. That might sound minor, but on a crowded flight deck where dozens of aircraft, vehicles, and crew operate in tight coordination, space and flow are everything. Less traffic jam, fewer bottlenecks, more movement. And then there's manpower. The Ford class operates with hundreds fewer sailors than previous carriers, thanks to increased automation. Fewer people doesn't mean less capability. It means fewer hands tied up in labor-intensive legacy systems and more efficiency in critical operations. Well-designed automation doesn't slow tempo, it protects it. Fewer breakdown-prone systems, less time spent on emergency maintenance, more consistent performance over long deployments. That consistency is key in sustained conflict. High sortie rates aren't just about one dramatic day. They're about keeping that pace going when fatigue sets in, when parts wear down, when the ocean gets rough. A carrier that can keep launching and recovering aircraft day after day without grinding itself down is a strategic asset. Now zoom out. A carrier strike group doesn't operate alone. Destroyers, cruisers, submarines, and support ships form a protective and operational network. But the carrier's air wing is often the group's primary offensive tool. When that air wing can generate relentless waves of aircraft, it changes how operations are planned. Commanders can maintain continuous air presence over large areas. They can strike multiple targets in sequence. They can layer surveillance, electronic warfare, and strike packages with less downtime between them. It compresses decision-making for the opponent. Instead of facing occasional, predictable strikes, they face a constant cycle of aircraft appearing over the horizon. Defenses stay activated, crews stay on edge, resources get stretched, tempo becomes a weapon. There's also a psychological dimension. Sustained air operations create pressure not just on equipment, but on people. Knowing that another wave could come soon, because the carrier can keep generating sorties, affects how forces on the receiving end behave. It forces caution, dispersal, and constant readiness. That slows their own operations. So, while missiles and bombs deliver the physical impact, sortie rate delivers the strategic squeeze. The Ford class wasn't designed simply to carry aircraft. It was designed to keep them moving, in cycles, in waves, in patterns that are hard to disrupt. Of course, no system is perfect. New technologies, from launch systems to elevators, have faced testing challenges and refinements. But the overall direction is clear. The goal is not just power. It's sustained, repeatable, high-volume air operations. Think of it like the difference between a single powerful punch and a machine that throws punches all day. In earlier eras, naval power could be about individual engagements, one battle, one decisive moment. Modern operations often stretch over days and weeks, with persistent air presence shaping events across large regions. In that environment, the carrier that can keep its air wing cycling at high speed becomes more than a platform. It becomes a clock, and everyone else has to live on its time. So when you see a Ford-class carrier on the ocean, deck packed with aircraft, it's easy to focus on the jets, the island, the sheer scale. But the real story is invisible. It's in the choreography. The elevators rising from below, the fuel lines, the deck crews moving in practiced flows, the launch systems cycling again and again. It's an industrial rhythm, tuned for war. Because in the end, dominance at sea isn't just about how hard you can hit. It's about how often you can hit and how long you can keep going. And the Ford class was built to make sure the rhythm never really stops.